Hello, people. Spoiled yourself with last night's score. Well, sorry. It's all about the journey. You know what I'm saying? Quick question. Do you make the COF object files yourself or do you use the library? We make them ourselves. The Microsoft documentation does suck, but it's better than the LLVM documentation. And it's actually not that hard to write them out. The annoying thing is that when you get things wrong, you get a very unhelpful linker error that just says the file is corrupted. That's the part about it that sucks. But apart from that, it's pretty good. God damn it. Like already it's happening. All right. Both dump in and link are unhelpful. Yeah, I mean, what would be super helpful to everyone who ever writes out object files would be just like a thing that's like dump bin, but that actually tells you when things are wrong. You know, like that should exist for every operating system because it would tremendously help people develop for your operating system, right? I'm not going to click on that Microsoft link. Basically, everything Microsoft does now is stupid, so I'm just going to think it's stupid if I click on the link. So I'm just not going to. All right, as often happens, I'm going to steep some tea, and when it is done, we will start the stream. I don't think our Weissman score will ever get to 0. That seems unlikely to me. Um, but it could get a lot lower today. That is a thing that could happen. I'm also getting snacks on deck. How many titles would I push if I would just use Unity or else? I don't know. Why don't you do that and tell me how it goes? Tell me how your life ends up. Have I seen Google's Fuchsia OS? No, but I will probably think it's stupid. Because I think everything Google does is stupid. Except for some of DeepMind. Everything Google does is stupid. Okay. We want to make gains with our Weissman score. That's what we're here for today. And I want to continue from where we were yesterday. We were doing some stuff with if and while statements, and that was good. We can apply some of that same stuff that we wrote to compares, because sometimes we do compares that don't go into if and while statements. Let me make sure we have a debug compiler. Yes. Make sure we have. No, not that. We'll do debug here, because I want full line number info on our output. We're dumping one of the arbitrary functions out of the Sokoban game. Actually, I think, no, it is. Okay. So there's a lot of room to move here. Some things I noticed. Here, when we emit an inline initializer for a complex struct, this clear instruction is like clear consecutive memory to 0 at a constant size. These are all consecutive clears because we never bothered to put them together. That would be a good gain. There's also some weird stuff happening. I noticed with a different struct that when we have a union, we're actually initializing all the members of the union right now. So we get to figure that out. So that's one thing we can do. I don't want to start with that, though, because that's not totally related. Let me look for some, not totally related to what we were doing last night. Let me look for some compare stuff. So here we have some compare stuff. I actually want to look at the code generating this. So here, first we're comparing against a constant 0. And like we actually have a variant of compare that's compare against implicit 0 that we can use, because most CPUs have that. That's how condition codes like work on CPUs, so it's good to have that. So this is especially ridiculous because it's 3 instructions to do 1 instruction, right? This is V103 is 0. And then is V101 equal to 0? And then is V102 not equal to 0? So this could really be V105 equals V101 is equal to 0. That's kind of weird. Line 90. Oh, no, sorry. Yeah, 909. And then I guess there's some short circuit and stuff happening here. And then we're doing that again here. Actually, I would have expected this to fold a little better already, because we're saying V110 is V104 not equal to 0. Wait, and then we're not using it. And then we're saying V110 equals V111 not equal to 0. Oh, well, maybe we use it. Oh, we do use it down here. Anyway, So here as well, we have a not. Can we do something about that statically? We have a not from V107 into 108. And then we're comparing. Right. Okay, so this is what I'm talking about, is that not stripping that we did on if statements, we could do right here. Because we want to know if this is not equal to 0, but it's knotted, right? So we could just test if the 107 is equal to 0. And that should be trivial question mark in principle. So I want to come up with a good abstracted way to do this. Problem here is when we do logical and or, we're already passing the left side. So we can't do any not stripping on the left side because of the control flow. Oh, and the reason we do that is because of the assignment version. All right, I'm going to put an incomplete here that we can't do this here. Not obvious how to cleanly get the left expression here rather than the left register so that we can e.g. fold knots, but it would probably be beneficial to overall program structure to do so. I'm going to write that down on my piece of paper too. Like, honestly, this assignment part, I don't know. I want to review all this. So, but this is not about gains. This is about cleanliness. So I'm just going to write it down. Because we're here to make gains right now. And this may enable more gains later. But first we need to see this. So I could do this thing where I go equals stripped not emit expression. All right. And then we're going to bring some quantum circuits into here. We're going to go C naught right? So C naught says like, well, I'll show you. It just says this. I mean, the quantum version of that is, of course, different. You can't XOR an enum in C++ without writing an overloaded operator because it is C++. I guess I can do this. Okay. Okay. So this is like a drop-in replacement for emit expression that strips knots. Yeah, I mean, I guess that's a thing. So our Weissman score is still around here. We're 412 instructions in this thing. Still 412, still 380651. So it did absolutely nothing. which is maybe not that big of a surprise. Or maybe it doesn't work. Let's go back and let me put this in a file so we can look at it. Okay. Was it here? Yeah, I think so. So we have and not something, but I think this is probably, the tree is probably this way. Maybe not. I can just set a breakpoint at line 910 and see what it is. See, if the tree is this way so that this is on the left, according to what I just said, we won't do not stripping on it because the frickin' thing. All right. So right. Line 909. No, not there. Ugh, what am I doing? Oh, okay. So we have to emit sub, by the way, and not the main expression. Now that's weird because that should have broken things if I got that wrong. Whoops. Okay. So we got a small gain, 380,325. Oh, we're 409 here. That was 412, right? It's probably lost in the mists of scroll back. Yeah, hold on. Anyway, we got a very small Weissman gain there. I mean, in as much as it fluctuates. So that was obviously, let's run the tests because no. Remember when I said when you mess around with things, you get an unhelpful error message if your object file is wrong? This is due to some stuff I was doing this morning before the stream, and I thought that I had fixed them. I guess it's just a warning. But I have to write that down. All right. This is good. Oh, no, guys. I forgot to pour my tea. I fear it's been too long. This is going to be nasty. Let's find out. It's been too long. Okay, wait. Since this is doing something, if I change this back, this should fail tests probably. At some point. Yeah, well, it says we have 0 tests. That's an error in the test program. Well, I mean, if the test program is being compiled badly, you of course never know. Okay. So clearly that did break something to have that wrong, which is reassuring. That's how we know that that's actually doing something, is if it's wrong, it's wrong. Okay, great. Okay, let me start some new tea because this is undrinkable, and then we'll look at this some more. Okay, we'll wait for that water to finish boiling. Now, I kind of want to do this left-hand side situation. Okay. Guys, I'm seeing bugs here, which is bothering me. Of course, anytime you do stuff like this, you add complexity. Actually, this can be taken outside. No, because the short circuit has to go after. We could factor this differently, and we may in a minute. Okay. Oh, you know what? So my snacks consist of popcorn, licorice, mango licorice, sea salt chocolate, sparkling peach soda, cinnamon roasted almonds, and hot tea that hopefully will not oversteep this time, and chartreuse that's hanging out over here from the chai station. So I think we've got our carbs covered, I think. Those are the snacks that are within reach, right? We have more snacks over there. Okay. I'm going to try to factor this. Okay. We're going to say if trivial I'm just refactoring to get rid of some of the redundant code that's in these two, because we evaluate the compare on the left-hand side the same way. So if trivial, we're going to say left target equals actually allocate output register interrupt type def bool. Okay, so that's going to be there, and then we're going to do this. Left knotted. Left is never going to be knotted yet, but it will later. So we have left BC there. We have left BC here, and this is going to go into left target, which is going to be op result register if we're not trivial, right? Okay. Okay. And this is a very non-SSA thing to do. So we might change this later anyway if we decide to be SSA, because we're putting something into this is actually a value number. We're putting something into that value number and then overwriting it later, and we could choose not to do that. Okay. So we make a compare that's maybe knotted. And here, could actually take this out. Then if it's an assignment, when we get down here, we do the assignment. And then if it's a short circuit, we add a new basic block. Oh, this is wrong. Okay. Let's see if that's broken. Well, it doesn't even compile, so there you go. Left. Oh. Wrong type. Okay. Let's see how it goes. I'm pouring my tea now, maybe slightly early, but maybe not. Certainly not as late as before. Okay, well, the sparkling peach soda is done. So that is what it is. Your professor said that using getters and setters and other OOPs are pretty annoying, but it's just something you gotta do you just gotta do it. You have no choice. The computer will not move the electrons around unless you use getters and setters. It just won't do it. The integrated circuit chip, the CPU clock, will not oscillate up and down unless you call a getter. Facts. Facts. Okay. So let's see if we can now massage this other thing down into here. Actually, let's, for a minute, I want to see what our target code looks like, because we were looking at a specific conjunction here on line 909. Fuck. Oh. All right. So it still looks bad. It's still... Maybe the most fruitful place to look for gains is not here yet. Hold on. Let me see where these are. This one is 3985, which might be where we're working on. Yes. And then 4180 is the other compare. Which is, I don't even know what that is. I guess it's this. And dot game is 0. All right, since I'm working on this one, I'm going to try to do it. I'm going to see if I can do it without making as much of a mess. Like, what even is that? I don't remember what this even is. This get R value from L value for assignment binary. Let's look at that. Oh my God, it's so steeped. I could have taken it out sooner. Okay. Right. So this is evaluating the left-hand side. Oh, you know what? We don't have to worry about this exactly. It can't. Let me think about what it means. If it's an assignment, so I think what I'm trying to do here is just be more efficient. Like, look, if you know you're doing an assignment in a binary, like a plus equals or whatever, then you, it's good to just have the L value there. You read from it and then you write back out to it. That's like actually gains already. And so the problem we have is that gain makes this other gain harder because we have this situation where I mean, I could make it even more complicated. We have this situation where we're just trying to maintain a code invariant that by the time we get here, the left-hand side of the binary expression has been evaluated. I don't know. I feel like this is complicated enough that I want to defer it. We haven't delivered any real gains today. We've deferred slight gains or delivered slight gains so far. I think we check this in and we move on to somewhere where it's easier to get gains for now. And I've taken a note that I would like to think about how to restructure this, but it's not that easy. It's probably like, I want to look at that whole, like the way that binary operators get outputted is something that it's bigger and more complex than I would like. So I think it's something that I would like to just restructure this regardless of this other thing. And then maybe that new structure will make it easier. Like I could make it happen. What I could do is say down here, oh, if it's not an assignment and we're doing bytecode dummy bin op logical and or, then let it be -1. And then when I come down here, inside here, we could just do that, right? Or the other way I could do it is do a stripped not emit expression. Oh, let's do that. All right, we're going to do that. And this is going to inform the refactor because I don't like to give up. I don't like to turn tail and run. Okay. All right. Oh, I already had a thing that said and or situation. This is part of the and or situation. We're going to say the thing that put me over the edge right now in terms of wanting to do this is that if I restructure this whole thing later, which like I said, I want to do irrespective of this, it's just more information to have that like, oh, it also wants to do this thing, right? Now, maybe that puts too many constraints and it makes the job too hard, but I know what here is an optional constraint and what isn't, and so I'll be able to solve the problem better. All right, so we're going to go here to stripped not emit expression and logical and or left knotted. And down here, we're going to pass this to these guys. I'm a little scared to pass it right next to another Boolean because that's a great way to make a mistake. Okay. That's actually not as crazy as it might have been. If that's correct, I mean, who knows? We probably won't get that much in the way of gains out of this either, but maybe the two put together is enough to go on the board. It's not really noticeable. Well, we're getting that number. We're going to call it 380.188 for now. Well, let's make sure the tests run. We have a small Weissman score improvement, but we're on the board. Not crazy. This is complete bananas to you. Try writing this entire compiler, bro. Okay. I'm hoping our next Weissman score improvement will be more dramatic than that. Let me go back here, because we did this thing where we get a constant. Like, oh, I need to regenerate this. Okay. So, oh, I didn't put it to the output. So line 4180 now. That's weird. Why is it saying line 4180? There's like not a thing. Is that line 4180 of some other file somehow? Now I am so confused. I'm just checking the other numbers to make sure they land on things, and they do. 3985. That's an if statement. What is going on? I am so confused. Does somebody else somehow have an instruction emit? No. Maybe it's getting inlined? No, this is supposed to be line of the source text, right? That's the definition of that. Why is it 4180? Guys, computers don't make any sense today. Everything else makes sense. I can go to 2928. That's an instruction. Let me go to later ones and see. Let me see if the line number is messed up somewhere. Oh, it's a control M, guys. Watch. No, it's not. But 4744 is off by 1. Maybe that's because I edited something. 4180 would have to be off by more than one. It would have to be like down here or up here. It's not that. It's probably this one. BC comment equals, set comment, BC, that's probably the is equal. Let's take a look. We'll see that comment on it if that's where that comes from. That's not where it is. Okay. There's no... What is that? Wait, did I rebuild? I did rebuild. Did I? It's... Oh, we made release. Guys, the line numbers don't match. Yes, somebody just typed that in chat. But I noticed it first. When the world doesn't make any sense, then you built release versus debug. All right. Okay. Now it's line 4186, general binary operator. I actually want to do some stuff there. How many of those are there? Minus, equals, equals, and minus, minus, times. So really the equalses are not that often. So I'm thinking I want to... Again, there's a question of how often do you frickin' do this, but let's just... Did I check in the previous Weissman gain? I think I did. Yeah. Yeah, okay. Compare. If it's a compare to, yeah. So that's what is equal, is not equals, and stuff. Okay. So we're going to say okay. We have this, evaluate to Boolean constant. Here we go. So we're doing a compare. And if it's known, if the right-hand side, you very often compare things to 0 or, non-zero or whatever, okay? If it's a compare to, and we do the right-hand side, then we're going to say, I just changed how all this stuff works. So we have this condition code that we got. Oh, that's even happening later. Okay, it can't be an assignment. I think I can do this here. Okay, so we're going to go if CC is equal or if it's one of these, we do shenanigans. We try to see if the right-hand side is constant, right? If literal if it's a false value for the type, so we're saying equal 0 or not equal 0, we can say we do compare 1. Okay. Okay. Actually, we don't need the equal or not equal. That doesn't matter, actually. If we have a compare 2, but the right-hand side is 0, turn it into a compare 1. That is generally a trick that we could do at any time during optimization, but again, it is likely to catch a lot of them here. Okay. Oh, actually, so here we could just do this. That all came together. Okay, so yes, that actually doesn't seem insanely complicated anymore. But is it wrong? Actually, let's not even, I want to see output. Look at that Wiseman score, guys. Does the game run? Why just right and not left? Oh, the game doesn't run. Okay, well, good Wiseman score is not good if the game doesn't run. The way that I'm detecting the thing on the right, let me... Yeah, no, it's absolutely true that we could detect the left being 0, too. The problem in this case is that because of the structure of the way these binary operators are emitted, we already outputted the code for the left. So for the same reason, that we had a situation I'm going to write that one down. I'm writing down cannot do left yet. Okay, so the one thing that actually I suspect is most likely to be wrong is like I moved stuff from down here to up here. I don't know. We'll just investigate a little bit. Let's run it on the tests because those could sometimes pinpoint specific things for us. Right register is never set. Yes, it's because it starts at -1. So we only set it if we evaluate this. Okay, one of the tests failed. String line 1369. So like wildcard match is broken for some reason. I don't really see any obvious compares to false here. Well, we could always just step through it. Oh, it's the frickin'... I fucking hate this. We'll try it though. I don't like that it puts all the module tests into one program. That bothers me. It just makes everything unnecessarily hard. It makes my life harder than it needs to be. Let's see. String, and it's in line. Okay, so we should be able to break there. I guess. What's it even doing? Oh, it's loading symbols from the Microsoft symbol servers. Thanks, guys. They know it's annoying because they say attempting to cancel will disable further symbol loading. All right. Why is my breakpoint not set? Oh, okay. This fucking program. It doesn't like its own. Oh, this might be the x64 backend being broken. Because remember, it was saying it didn't like the debug info due to some unrelated thing. So we could try the LLVM backend and hopefully it'll be good. Okay, let's try it again. Okay, this worked. So x64 debug info is completely not working right now, apparently. That's a problem, but I want to make gains. I don't want to fix that right now. All right. I don't even know what I'm looking at. Stir. Pat. Mhm. The problem is this code is kind of unscrutable to begin with. Like, this sure seems like that should have... Oh, God. I don't know what... The one right before. Which one are we in? Like, it's not displaying the information to tell me... Oh, my God. Which one are we in? I guess I can look at the hex number and say 7FF 6B8 C2 4B32. So it must be this one. Okay, well, rip. Okay, let's try it again. What is this function trying to do? Okay, if it's a star, we keep going till we see a match between the two things, which we should match here. Wait, why did we jump to there? Oh, because we returned from here. So we somehow screwed this up. This if not stir.count. Or this part. No, because stir.count was stir. Okay, well, let's do it again. I'm going to go in. And then we're going to go into the next one. Wait. What? Okay. Boy, this is a slow wildcard matcher. Okay, it's this one. So, where are we exiting? I should maybe print our intermediate representation. So, yeah. So this first part, this is just loading stir.count, which is, and comparing it to 0. I don't understand this code at all. Why is it? Okay. I didn't look at the status code. But anyway. Let's just see if we jump or not. Wait, what's RAX? It's 4. So stir.count that should not jump. Don't jump. Okay, we didn't. Good. XOR EAX, EAX, move ECX, EAX. So A and C are both 0. Move RDX. Okay, so this is going to be pat is going to be, or ampersand pat is going to be RSP plus OX140. Yep, same. Okay, this is reading pat sub 0. So we get RDX is pat sub 0, which is a, oh no. Wait, what? This is the count element of pat. Oh, we're doing a frickin' array bounds check. We're seeing if 0 is within bounds of the array. Okay. Yeah, this would have been an array bounds check fail. Okay, so now we probably actually do the work. So we move. That's the data pointer of the string. All right, that's .exe. Is it a star? No, it is not, because we set if not equal, right? So this should be true. But wait. Why are we even doing this? Like, this should be a short circuit and, right? Or, I mean, maybe they also don't generate that. I assume they don't generate that. This is an optimized short circuit and, even though it's a debug build, I don't know. I can't tell what's going on at this point. Let's just look at our intermediate representation. That's going to be easier to understand than this, because that is what is wrong. All right. Okay. So if I go to this, all right. Wildcard match, line, here, line 420. Okay. We actually could probably add some more comments to this, but we move V11 from V4. We compare. Is it equal to 0? Actually, here's what we can do. On our thing that we just did, so we can even tell exactly which one. Oh, whoops. Hold on. Okay, line 420. We're not seeing any comment. Why are we seeing no comments whatsoever? Did we stop drawing comments at some point? Accidentally? I see none. If we're in debug, what? Are we never getting there? Is underscore debug the wrong thing? Am I going insane? Okay. Maybe just none of these lines have comments set on them. Because we are getting there. So wait, that means... Okay. That means... Wait, we were just seeing general binary operator all over the place. Maybe... Like what? Sometimes computers ain't making no sense. Okay. This is a compare that we didn't edit. Unless my basic refactor of stuff moved it around in a bad way, right? That could have happened. This is just like this compare got to this part of the code and we didn't do anything to it. That was a bug. But I don't think that would... Yeah, that wouldn't fix this. I don't get it, guys. I'm just curious about something. Okay, hold on. Okay, this is, I was looking for this jump and I wasn't seeing it. I was like, wait, what? So this is a short circuit where we jump to here. All right, let me just look at the code. Wait, line 420. Yeah, okay. Oh boy, guys, I must be tired from working hard for like a week. I'm going to try to pull it together though and figure this out. It's one of those things where if I'd looked at the right thing in the first 5 minutes, it would have been solved and we would have just moved on. But my brain doesn't have enough brain in it right now. This happens sometimes. Okay. We compare V12 is V11 equal to 0, which is the string count. We jump 3 if V11 is equal to 0. Which looks really wrong to me. See, here's the thing. We're jumping 3 if V11 is equal to 0. Basic block 3 jumps 4 if V12 is equal to 0. Oh, never mind. That's actually fine. These are mutually exclusive. So this is our return false. Okay. V13, 0, that's going to be the array subscript. V14, probably the L value or the count for the array bound check. Yeah. And then V15 is the data pointer. We go some bytes into V15. Like what? I don't know about that one. I assume V5 is pat. And this is the data pointer. We're going 13 bytes into the data pointer, which doesn't make any sense to me. We're supposed to be subscripting from 0. So that could be an unrelated bug that we just happened to expose. This could be why it's so confusing, is maybe we exposed something that was already a problem. That's what took like 2 hours yesterday or whatever. So we're moving V17 into V16. We're comparing that against OX2A. And then knotting this, right? This is weird. Is that where we were just... Yeah, like a compare for not equal doesn't need to happen. I'm going to put that on the gains list. The thing is, when you have a logical and or an or in a tree like that, with multiple conditions, the thing coming at you is already Boolean. So a compare of not equal doesn't do anything in that case. Okay. This is what looks wrong to me about this. Actually, let me check the print. Yeah, so the offset, I guess, goes in index B. This is one of the few instructions that I've been wanting to get rid of, interestingly, but offset register. Wait, offset is a register. Oh, so that's R13, which is 0. Okay, so the print is broken. Good. Oh, that's V. Good to know. So it's V5 plus V13, which I should have guessed that. V13 is the array index. It is 0. Honestly, at first glance, this looks right to me. The problem is I can only step through an LLVM right now because I broke the debug info, unfortunately. I could take a derail from trying to make gains, which I guess is what's already happening right now, and try to fix that. Okay, hold on. Let's test the theory. Actually, let me look at this one more time. V11 gets the count value. V12 is sort of, is that equal to 0? Jump 3 if V11 is equal to 0. That's a little weird. This has the not stripping on it. guess. Let's go back there. If that's not stripped, why did we evaluate it? As equal to 0. Oh, because that's what we do when we not strip. Okay. But then why is this V11? I feel like maybe I messed that up. No, that's actually correct. I guess. Okay, I think this is supposed to be left target. Wait. Yeah. Don't make mistakes. They're costly. Did I catch the and or and bug? Yes, I did. I did see that. Did I look at Jeffrey Haliki's comment yet? Nope. I don't see any such thing in the scroll back. Oh. Yeah, no, I fixed that one like a long time ago. Maybe he wrote that a long time ago. How would you debug without intermediate bytecode? Well, you need some kind of intermediate representation if you're going to do anything interesting. Do I have different branch? No, I don't ever branch. Branches are not really a good idea. I just don't commit things unless I don't think they will disrupt anyone's work. Okay, well, I guess we fixed that. And let's test the game. This may mean, it also may mean, but it may mean that we get to put our gains on the board. Finally. Let's see what our frame rate is in Promised One now. Yeah, the problem with source control branches is they're implicitly going out of date all the time, right? I don't know why that's so slow. This frame rate seems to have gone down since yesterday. Maybe that's about what it was. When I'm not streaming, it's like 18. But, you know, that's streaming versus not streaming. All right. So what's our Wiseman score? 378670. I'll take that. 378670. Okay, we're finally starting to see like 2,000 gains is starting to be non-embarrassing territory. Still plenty to do, but so there's one thing that's disturbing about what we were doing before, which was before that problem happened, you know, we had that if statement in the other place that I typoed wrong. I copy pasted wrong at first, and nothing broke there when that was wrong. Nothing additional broke. We had this problem. And that means we don't have enough test coverage on Boolean operators. So I need to put down on this piece of paper like lots of tests of and or. Now that I know what to test for, we want to test that the non-short circuited versions don't break, that having knots in there doesn't break, and so forth. Having insufficient test coverage is very not good. Having way too much test coverage is also not good. Okay. Let me go back and look at the thing that we had recently done. We have a couple no check-ins. Like this didn't even, I'm not sure what happened. This didn't even activate. Like we never saw this. All right, hold on. Let's go back to our, let's revert the dump that I put in here. We'll go back to main and put back our dump here, right? Okay. This is actually not that many instructions anymore. It used to be a lot more. Okay. So this should be in there if it ever happened. I really don't see it ever. Let's put it in the file. Well, I mean, it doesn't mean it didn't have. Obviously, it happened in the program because we have fewer instructions. It just didn't happen in that file or in that function, which is weird. Let me delete this. Delete this. I'm going to change this because these greater thans look funny. Okay. So let me just look at some of the Booleans in that file. Right? Well, not the ones in static ifs, because those... so for example, we have our line 929 here. 929. Oh. Jump 32 if v124 is not equal to v125. But that's a constant 0. Like, we literally just did that. Oh, but that's a jump. So this is one of the things where the optimizations are wrestling with each other for a little bit. The thing that I just did is on compares, right? Here we folded a compare into a jump condition. So then it didn't output as that other thing. Refresh helps, I've been told. Although we could put this in maybe split condition helper, right? So we get the left, we get the right, we break away any knots. And if, again, if split right is equal to 0, does anyone else call the helper? No. Okay. So oh, no, we won't do it here. We won't do that here. We'll do that here. So these are very similar in fact, they're the same operation. Hold on, no, not there. Not there. Here, this thing that we just did. This is split right. If it's literal false, we do a thing. Otherwise, okay. Like that, I guess. Decent reduction in Weissman score. All right. Three 77725. 377-530. 377-629. We'll call the 629. That's in the middle. Now updating Weissman score. Okay. All right. Oh no, I forgot my T again, guys. I got so excited about reducing the Weissman score. Oh, this could be bad. This could be the day of very inefficient T usage. A day that will live in infamy. It's actually not that bad. Any idea what the lower bound is for the score? We don't know. We do not know. All right. So we got some Weissman score reductions. There might be some other spots to do that similar operation. But Maybe that's enough in that area for now, and we should go after other gains. There's other weird stuff that we're not doing that maybe it's not common enough to do, because again, we're not trying to do every optimization in the front end. We're just trying to keep the traffic down, right? And we're doing great at that so far. We're keeping the traffic down. A couple of these that we've done are questionable in the sense that I'm not sure that the added complexity is worth the Wiseman score increase, but we can always take some out later. I think it's worth doing one more in the logical knot, actually. Uh-oh, I left a no check-in in. All right, so the other one is in the logical and logical or. For this second compare, we often have not equal and it's already a Boolean, right? Doing a compare of Boolean not equal 0 is not worth it, right? So because it's a no op. So let's try that. If does it have to be Boolean? I mean, it's really... We do want to make sure it's the right size. So I think keeping it to Boolean is, yeah, for now. Okay, so if, we're just going to do logical and here. If this is hard to think about. So we have the left type. We have the left value in left target, which is a Boolean. Let's make left target left Boolean. That makes more sense. Okay, So left Boolean. Now, if we're doing an AND with another Boolean, and the compare if right is Boolean and right CC is CC not equal, then Boolean not equal false is a no op, bro. So just don't emit it. Otherwise, we do all the stuff we were doing. We do the compare and the AND. Now, if we're ANDing, oh no, we still need to do the AND. Okay. In right, oh gosh. I had right Boolean or right is Boolean. So if right is bool type, okay. Otherwise, right Boolean is this, and we put that in there. And then we do this. So it's the logical AND. Okay, there we go. We do a bitwise AND or a bitwise OR. I actually want to get rid of that argument because it's not worth passing it in now. Okay, so if we're doing logical AND the right is a Boolean and the comparator is not equal, then right Boolean is left Boolean. Which means you don't need to do the AND or the OR. Or the AND, sorry. Oh, actually, for anything, right? If it's a logical AND, wait. Oh, my brain, I don't have enough brain, guys. This is simple, but my brain isn't doing it. So if it's a logical AND the right is a Boolean, it's a no-op on the right. So ANDing, there's no point in ANDing if it's a logical AND. And so, wait, no, there is a point in ANDing. It could be false or true, right? Duh. That's why I put this down here. We need to do this. We just don't need this compare. But it's not that right Boolean is left Boolean. It's that right Boolean equals right register. That's the brain fart that I did that was confusing me. So the right register is already represents a Boolean value, right? Otherwise, we need to generate a Boolean value with the compare. And actually, this part doesn't matter. Okay. And actually, that's the same down here. This is a chunk of code at this point, because it's literally all of this. So we actually could instead of factoring it into a separate function, what we'll just do is we'll say if it's not trivial, we do this. Then we do all this. And then if trivial, yeah. Okay, whatever. We'll figure it out. Left Boolean, not defined. Wait. Right. Okay. I have to run the slow LLVM tests because I broke x64. Let's run Sokoban at the same time. That is not a very big Weissman score increase. I was expecting more out of that. Okay. Okay. So let's do the better factoring of this together. So we're going to go, if not trivial, we do this stuff. Okay. We set up the jump. That makes a lot of sense. Then we do these. We evaluate the right-hand side. If it's trivial, we do this. Else, we do this. Wait. I kind of screwed up. We're still doing some extra work, which might be why our Weissman score wasn't that good. Okay. So I guess we just do a register to register copy here. If it's a short circuit and we got here, then the result is the second value, right? Because we only got here if it was true. If it's a short circuit or and we got here, then the result is the second value. So like, this isn't a compare. This is just a register to register copy. What is it? Move A to R. Am I wrong about this? Okay. I was guessing that I had broken something right there. Let's run the tests and see what I screwed up. Okay. If it's not trivial, we jump based on this condition code. Let's move this down here. Oh, you know what? We actually need strip not emit expression to tell us this to be correct. All right, so we have a fail. It's okay. I'm just going to keep working on this a little bit. But this is getting for type of sub. Because we care what the value is of the... Oh, you know what? I think it's just called type. Dot type. This is a better solution because this is a localized concern. Nobody else who calls this is going to care, I don't think. Maybe. We'll see. But I don't want to contaminate that function with things that most people don't care about, and we can check it here anyway. So if it's a bool, you just blah, 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 blah. Okay, so if right is bool type, and it's not equal to false, right? Otherwise, we make a new register or value number. We compare with the condition code against 0. Right register, and we generate right Boolean. If it's a logical and, or an or sorry, if it's trivial, we do a bitwise and or on the result Booleans, right? So as not to generate jumps and basic blocks and all that stuff. If otherwise, for now, we're copying right register to op result. This is wrong. It's right Boolean, guys. That might not solve all the problems, but let's see if it fixed this. There's some chance that it did, some chance that it didn't. Hey, look, it did. Just looking for the bug is worth a lot. Okay, this is good though, because this means we can still increase our Wiseman score by just saying well, it's weird because in this case, we need to do it. Like we say, So we don't use write Boolean so if it's trivial, write Boolean is write register, else we move that to result. Okay. Otherwise, if here, if trivial, write Boolean is this, else okay. That kind of makes sense. It sure looks cleaner. Did I break it again? Wish I could run the x64 tests. I probably can. Well, our Weissman score went down a little bit. Not a ton, but like a little bit. 282, 172, 330. I'll call it the 282. 76. Oh, that's a 76. Look how much lower that is. Oh my gosh. Yeah, well, it's 282. Small Weissman score benefit. All right. I think we're done with Boolean operators for now. We're going to wait for these to finish. So, next, I want to do the struct initializations. Because those should be relatively easy gains and or produce assembly code I will be able to look at and maintain greater self-respect. Because as soon as I give the beta testers the ability to do these dumps, which actually they already have, but they'll have better dumps to look at, they'll just look at these struct initializations and go, what the hell? And I'll just have to be like, well, you know, I have a lot to do, man. Don't at me. But I won't have to say that if I actually do this. Okay. Judging. Yes. Yes. Okay. Well, did we run our newly Weissman scored game? Seems to work. It's not really getting that much smaller executable size wise lately. Interestingly. Let me try the x64 tests because they do go a lot faster. Oh, whoops. Like this debug info corrupt thing is bothering me. I'm wondering if that's happening on all of these and we're just not seeing it because the test program is like what if none of these are really recompiling? I mean, it does say it's new. Actually, let me do it again. Okay, so it is recompiling. So that confusion we were having earlier was probably just that I broke something that only exhibited later after I broke it, which can happen. That's definitely a thing. Okay. So I have a note on a particular place that we're going to go look at again. That has one of these struct initializations that's bananas that we will fix. It was line 832. It should be still around there. Haven't really edited this. Yes. So here we go. This is a struct initialization that, let's say the technical term for this is could be better. That is the technical term. It is still tremendously better than like JavaScript or something, but you see that it could be better. You're ready for huge gains. Okay. So let's take a look at where this happens. Line 832, or no, 5691, 5719. Emit member address. Oh, well, obviously. Okay. So when we emit the initializer for a struct, we do this two different times. We call this function. One is just every struct that has non-zero data has an initializer function that you can call at runtime. So that gets generated for you. But also, when you have an inline just struct declared on the stack, we don't make that into a function call, right? We just like spew it in there. And it's the same code either way. So what I'm going to do is try to sort this out so that I can make like a clear list. Because right now we're literally visiting every member and just going to the thing, right? Now again, we only get here if some members of the struct, let's see what struct it is. But we only get here if some members of the struct have non-zero data. It looks like this struct has a single one in it. Render key, let's look at, it has a single one in it somewhere. Right, so this is a render frame. First render batch ID is probably one. Or maybe something in render context is. Anyway, it's not all zeros, which is why we're even here. It's mostly zeros. This is 0, this is 0, this is 0. Probably this one. Is it a... Oh, we don't show sizes here. Okay. So let's actually look for that. First render batch ID is 1. Yeah. So we want to somehow batch together clears. So I'm just going to do some really stupid thing, and then we'll try to record it on the struct later. But for now, we're going to be like, we're going to have a clear list. And we're just going to do the dumbest version of this possible. Oh, let's actually say, let's do this. So, oh, I'm in C++. I'm in C++, guys. Just don't switch languages halfway. Okay, so we have a clear list. If it's constant, we just skip. If it's imported, we do some things. All right. So okay. If so we checked if it's uninitialized. Okay, so if it has non-zero init data, then we do this. Else seer list. Yeah. My brain just jumped on me. So I was going to look for emit member address, just because it looks like it's just doing this. Yes, okay. So add to clear list. Okay, here's what we're going to do. If clears already has items, do I have a way of peeking at the last? Oh, I can just say peek. Oh, but that doesn't give me the pointer. All right. Okay. Clears the peek pointer if a little bit over generous because we have union spam right now, hopefully fixable as a separate issue. Maybe, I don't know, I just work here. So if the base is, and base is less than or equal to, base is less than or equal to last base address plus size. New end is last base plus okay, anyway, so the new end is base plus size. Okay. Okay. So we handled it if we did this. If we didn't handle it, that. If we didn't handle it, okay, so emit clear list of clear list. Okay, so for clears, base address of the register. emit member address from mem register. So we have mem register. Okay, int mem register. So for clears, we don't have a 0 things plus size. Yeah. Okay. We instruction memory sized we might want to put an offset into this instruction, but okay. Add integer add to constant. We need a clear base, which is allocate output register. Builder allocate output register of interp type def general pointer. So clear base. Where does the constant go? And B. And into clear, mem register, into clear base, and clear base of a given size, like that. Oh yeah, I'm not passing. So many things wrong. I have list and last. Okay. Emit clear list needs to take this. Okay, 5739 for list.clears. Dang it. Okay. What's going to happen now? It's anybody's guess. So this struct initializer was at somewhere. It shouldn't be that hard to spot. There's a lot of clears. There we go. Line 832. And we died. Add to clear list. New entry size is greater than or equal to clear size. Oh, in the case of a union or something. Let's make sure that that's due to a union or something and that I didn't just screw something up. But I think we just say, oh, it's contained inside. Okay, so what is the current clear? It's base 0, size 12. Our base is also 0. Our size is 4. Let's verify that. Line 248 of math. Oh yeah, oh yeah. Like it might be that we already, wait, the size is 12 already. So that would be like this one. And then we're getting to this one later because we sort of did it in the other way. You know, honestly, this should have an equal dot, dot, dot. But we're not going to put that in yet because we want to test this case. This is fine, actually. Oh, you know what? We didn't set the new entry size. That was wrong. Okay. I forget what line it was at. Let's look for clears. It was 8 something. Okay, it's not as many clears. We clear 48. That's much better. Then we add 48, and then we clear again. What's the deal with that? Like, why are we still doing this? And then we clear. So like, oh, these must be substructs that we don't handle yet. We can step through it and verify for line 832 or whatever. But did we get a, oh, we did get a Weissman score improvement, guys. If I'm not mistaken, that is drastically lower than our last one. Does it run? It does run. So let's run the tests, and then we'll continue to improve these gains. But if the tests work, we're going to run the fast tests, and then we'll run the LLVM tests after just to verify that these aren't lying to us, because I still don't totally trust it. Sounds like a bug. No, it's that the code that was there before was just really bad. And I knew it was really bad, but it was just like, I knew it was really bad. Just had other things to do. Like you guys know, I'm always doing stuff. I have so much to do. So when there's something like that that just like works, it's okay to leave it for a while. You're not going to get the best Weissman score if you leave it for a while, but you know, it's part of life. Not everyone can have the best Weissman score. Look at that. Look how good our score is now. What does equals dash 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 do? That just says that that member is uninitialized. So the deal is we're using placement. Placement is like a union, but it's like a linear version of it where you just say these members live where X does. And so they overlap. So we're saying don't try to initialize this because the memory is already occupied by something else, basically. Okay. That is a good enough Weissman bonus that I would be happy with that if that was all we got today. But we're going to get more. We're sort of hitting 18. I mean, it's very variable right now, but it's not bad. Oh, and if we really want a bonus, this wouldn't go into our Weissman score, right? But for all these clears in our x64 backend, this is going to be our bonus to this stream. Once we're happy with Weissman score, the x64 backend uses rep STOSB for large clears for anything bigger than 16 bytes, which is by itself slow. If we just did rep STOSQ for cases like this, it would be faster. I don't know if it would be noticeably faster, but there's like a lot of these, so maybe. Does place work with SOA? There's no such thing as SOA. We are at more than 15% off the original Weissman score, which is pretty good. Does rep STOSB retire one store per cycle? I don't actually know the exact speed. I've just been told that you want to use the bigger ones if you can. Is this place strictly better than doing anonymous union blocks? I don't know. What do you want to do? What do you mean by strictly better? Busting out some iced tea. Okay. Does it provide any benefit over the other way? I don't know. What do you want to do? What do you consider a benefit? What I would say is you might find it hard. You might find it hard to do this with anonymous unions. I don't know if it's possible to do that with anonymous unions, but maybe you could do something really crazy with that. Okay. All right. So what I want to do, I want to verify that the fact that this clear list doesn't have more stuff in it. Or rather, the fact that it has too much stuff in it has to do with us going into another struct. We could actually, so like we call emit initializer here. Yeah, let's just verify it, but I'm pretty sure that's what it is. So let's go back to our very happy Weissman score, which is going to get happier. Will lower Weissman also improve the LLVM performance compile time? It should, yes. I don't know by how much. I'm not really tracking it because honestly, again, like LLVM, like it's helpful in the short term for LLVM to be faster for everybody, right? Because that's faster compile times. In the long term, we want to be generating optimized code, right? And so it's like, it's hard for me. And also, I just have so much negative emotionality associated with LLVM at this point. It's hard for me to, I don't know. You know what I'm saying. All right. So here we go. This is line 832. Do I have that site? Yes. So I'm going to go emit initializer for line 832. And the problem is there's a lot of files in this project. So it might take a little bit of stepping to get to the right one. But we'll try it. Have I ever considered making vectors an internal type like int instead of a user level one? No. It doesn't seem worth it to me. He was watching an early video on YouTube and I sounded optimistic about LLVM. I mean, that was 6 years ago, right? I will say, I mean, I don't want to, again, I have to be very straightforward. Like LLVM provides us a lot of value right now, right? We wouldn't have an optimized build at all right now without it. It's just such a pain in the ass and it's so terrible in so many ways, right? But I'm glad that we have it. I'm glad that we have that capability. It means that our beta testers, for example, right now can generate pretty fast programs, which they wouldn't be able to otherwise. So, you know, there's value there. There's a lot of value there. However, long term, we got to do something else. How are the gains coming? Look on the screen. Look on the screen. Okay. Now, we're doing emit initializer. Site file name. Light probe, wrong file. Tests, wrong file. Main, only third time. Okay, so we're going to start stepping through here. And we're going to see probably the clear list for the first few members get bigger. Right, so that's the first thing. I think it was like 48 bytes or something. So we have 8 bytes so far. $16, 48. Okay. That's probably the union item. Oh, wait. Oh, was that? That was weird. Like what? Hold on. Okay, so we're going to go. So we've got 8, 16, 48. The new base address stack allocation. I keep changing. There used to be a variable directly on here. Okay. We should skip if the size is equal to 0 in this loop, by the way. Base address 48. Yes. It's right at the end. Base is greater than or equal to clear base address. Yes. Base, clear base address. Oh. Bro, that was the mistake. Okay. We're still going to have to do sub members and stuff. But in the meantime, I think we have just improved it. Okay. Let's see what our Weissman score is now. Look at that. Three six six seven four four. 366470. 366696. We could call it 366696. That's the middle one. Yeah, well, we'll do this one. That's a good middle one. 366658. Wow, guys. This is more Weissman score than I thought we would get today. I sort of thought we got all the low-hanging fruit yesterday, but it was not so. Actually, let me make sure the tests run. Because if they don't, then I don't remember what the Weissman score was supposed to have been. We're going to have a bug snack stream later tonight where I figure out why the debug info broke. BraidGame.com is dead. Dude, I just rebooted that machine like 3 days ago. 370572. Okay, well, that sounds about right. If we could somehow get 336, that would be astonishing. I kind of don't believe that that's possible, but it might be. We still have some pretty major items. Let's just play a level. Let's just play the game. Like Heroes 1-1. All this is running with our high Weissman score output, or low Weissman score output. Oh, it put us on the overworld. Because we have I think that's a temporary thing that we have. All right. 60 FPS on this level with a debug build. Let's see how Promised One is doing. Probably not anywhere near this, but, you know, much more in the 18s. It's 1718 now. The reason this is so much slower is it's just got a ton of entities. And we run a lot of code per entity right now still. But yeah, that's our debug build that we generate in like 0.6 seconds or whatever. Let's make it in release. And then I'll check this in. Decent. I feel like the compiler is getting noticeably faster as well. Like this dump time is with that, or this compiler time is with that dump output and while streaming. So like, I don't know, man. If we don't dump 636, 637, 630, so if we weren't streaming, we might also be almost be in the fives. I don't understand why it's so much faster, but I'll take it. I'll take it. Also, keep in mind the computer is just sort of randomly faster or slower on some days. But that's a very consistent compile time right there. So that's great. Yeah, at some point we will be faster than the linker. We're getting there. I mean, it's a little bit unfair because we're linking WWise, which is WWise is the LLVM of the audio world. Let's put it that way. So We are giving the linker a lot to do, more than we wish we were. But yeah, at some point it'll be faster for us to compile than to link. What does WWise do for us? The specific audio people who we are working with wanted to use WWise because that is a system that they're familiar with. And we had a built-in audio system from the Witness, but it doesn't have much in the way of features, and it really doesn't have a UI at all. Like, it's just not very user-friendly. And so we made the executive decision that we would let these guys use WWise, but in the long term, we're going to have to port their work off. Because in the long term, like, I don't want to be tied. Like, I want people to be able to play this game 30 years from now, right? When WWise doesn't port to whatever platform they want to play it on, right? So we're going to have to port all their work off WWise eventually. But until ship, we will let them use it and link it. Okay. Let's turn the dump back on. And see what our... I think we should check in this Weissman score into source control. There's a bunch of other things we can do, though, like, oh, whoops. Invite code builder. We have a no check-in. Oh, wow, we haven't checked in since that. Oops. Hold on. So basically, if it's logical and, we do CC equal. And if it's logical or, we do CC not equal. Right? I just wanted to get this out of here because we have a lot of condition codes now. So like having an extra variable called CC that isn't even very intuitive. Like we had that from before we even had is logical and. All right. So let's actually do this. This is going to be extra lines of code, but it'll be better for people looking at the dumper later. Actually, right now, people looking at the dumper will not get comments, but here we're going to tell them if it's and or. Better. When they get comments, we will do that. Someone was asking if it's possible to clear the whole struct and just set the initialized members. Yes, it certainly is. However, there are some cases when you don't want to do that. Like if a struct has an 8 megabyte uninitialized buffer inside it, right? So there needs to be a heuristic there. But right now, you are correct that um, the opposite is true, where um, how would I say it? Uh, like one byte set to one between two zero clears that are large will make us do two zero clears, right? When we could just clear the whole thing and poke the one, right? And so I think we're going to want to do some kind of gap fill situation. Does the language provide facilities for using the bytecode directly? I mean, that's what compile time execution is. It's just, no, we don't want you using an interpreted language. We've been doing that for decades. It sucks, guys. Stop doing it. Okay, let's run tests. We'll actually run them in release. And then we'll check in. I think that was the last no check-in, right? Oh. Oh, well, we did clean that up as well. Dude, I think I can compile my game like 6 times in the time it took to do that. All right. Game. Quake 3 engine accepts bytecode and then produces machine native code when it actually gets played to allow for portable mods, so it's not really interpreted. But that's what the compiler already does. Like, you would just link the compiler as a library to do that, I guess. Compile time code is not currently compiled to machine code. It's likely that we will do that in the far future at some point. Medium future. Okay. Great. Great. It's so great. All right. Now what? I think we look back at the clear that we have, and it's probably still going to have some holes in it or whatever. Let's see. Oh. Oh, we do have dump turned on for that. Okay. 832, 822, something like that. Wow. It's one clear. here I screwed up and always generated an add, which is not necessary. So let me fix that. That'll give us some gains. Maybe not that big compared to the gains we just got, but it'll give us some. So I think, you know, we can definitely do more work on this, but I kind of want to wait until I see bad cases, or maybe not, because the gains could be so big. Maybe I'll dump a bunch of random functions and look for clears in them. Let's set the comment on that as well. Emit clear list. Set comment BC clear struct members. Initialize. As you can see, it's a clear because there's a clear. So, okay. Int clear base. If it.base address, we have this, else clear base equals mem register. There we go. That will be at least a small gains. That'll get us to Gainsborough, Kentucky. 365,795. 365,981. 365,933. 366. We're going to throw that one out. That's just a dirty outlier. Oh no. Well, I guess that's what our Weissman score is. 366,043. All right. Any questions about what's going on? I'm going to take a 5-minute just brain break. Maybe get some ice cream. Maybe make some more tea. And then we'll go on. But like, any questions? I'm not sure what tea flavor to get. All right, nobody has any questions. Nobody cares. Nobody cares about anything. Look at our amazing Weisman scores. They're so good, our Weisman scores. So what is... So if we can get down to 350,000, that'll be a 20% improvement, which is beefy. I don't know if we'll be able to get there, but we might. What kind of ice cream? This is double dark chocolate gelato. What kind of texture format does Sokoban use on disk? I don't know. We have a texture compressor that Ignacio did. It probably uses like a DXT5 still because that's very common, or maybe like BC7 or something. I don't know. Any other compiler-related questions? You read on the Jai Primer page that I will have capture blocks. That's not by us. Don't believe things you read on the internet. QAnon told you about captures in the basement of the pizza parlor? Yeah. You got to get nice and soft ice cream, so I'm mashing it up. Mashing it up. What about model format? It's just a model format we made a long time ago. Like the question is, asking what model format should I use is not a very purposeful question, right? The question is, in what format do you need the data so that you can render it, right? Or process it in whatever way you want to process it. That should be your model format. Does Cranlift look promising? I think appleberry juice looks promising. How does the immediate execution execute the bytecode if it isn't compiled to native code? It interprets the bytecode. Just saving the big block of memory that is your model data to disk? Maybe. I mean, is that good? Can you use that effectively? Okay. Look at that. We're compiling fast. We are back up to like 6.6 instead of 6.3 for mysterious reasons. Okay, I want to dump some random functions. Did we check in? I want to dump some random functions and just look for clears and see what they look like. Oh yeah. You're asking because you thought there might be something obvious you just didn't know about. I mean, like, it's just like what do you want to do in your game? Like, yes, it would be good if there was a ready-made model format that you could just load, but the people who decide on model formats don't care about the same things that people who want their games to run well care about, so there just isn't such a format. And even if there was, you would probably want to tweak it for yourself eventually. So I think you just do your own and you make it be what you want it to be. OBJ is clearly best. That is potentially true. All right, let's see what we can dump. Why don't I go to simulate? Because we haven't really dumped anything there yet. Update gem and slot Visual states, we could dump that. Sure, it's got some for loops in it. That'll be fun. Oh, this is a big function. Let's dump that. Let's dump our main simulate function. Why not? And then let's go to Entity Manager. That doesn't really have anything huge. Entities. Actually, let's go to Sokoban and do level reevaluate. Post move reevaluate. That'll be fun. Okay. We're dumping a bunch of things. Oh, and you know what I need to fix? When we dump things, the name doesn't print correctly. We say no name every time. That's lame. So let's figure that out. Debug and me. All right. Still no name? What are you talking about? Oh, this is only if debug. You know what? This is useless. All right. It still says no name. The fuck? Oh. Why, yes, I'm running debug compiler. RIP. That's fine, though. All right. Simulate. Okay, we don't need this number. Debug name. Lambda load info file name. Get fully pathed file name. Okay. Okay. Really? Lambda is undefined. Hey, everybody. Oh, the fully pathed file name C version. Oh, we don't free this. Lol. Okay. Simulate. At simulate line 222. Stack size 288. Okay. Now what do? Oh yeah, we output this to a file, and then I just want to look at clears. Oops. Okay. Clear. That clear looks fine. It's a single clear. Clear. That's a different clear. That's not an initialized struct members clear. Let me see. Is that a memset? Oh, so, right. At top level, when we have an array, we do that. Now, the interesting thing is we know these guys are next to each other on the stack, and we still clear them individually. That's okay for now. We're not going to worry about that for now, although it's interesting to observe. Clear, clear. That's it. I don't see a lot of spammy clears in these things that we have chosen. Let's try animation graph. Send message. It's the very first thing. All right. Okay. We have clear. I mean, what I really see a lot of when I look for opportunity for gains is I see a lot of stack lees. Well, I don't down here. I do see a lot of stack lees. From line 420. Line 210, line 420. Let's take a look. Add emitted string literal. Right, that's for setting up a string. So we've got a constant. That's actually fine. These stack lees, line 210 stack lees are maybe okay. Except, of course, I mean, there's better ways to do it. Like, because you already have another stack lee, for example, you could just add a constant to your moves here and you would be okay. But really, I'm hesitant to put that because maybe maybe a different instruction is better. But these stack lees down here, just so we can move things in. Actually, that's putting a pointer somewhere. I don't know, man. Should you worry about doubles instead of floats in gameplay simulation math in 2021? I mean, I use floats. What you should use, I don't know. I mean, if you need doubles, you need doubles. The thing is, you shouldn't ever assume that the computer is faster than you need. Because it's not, probably, unless it is. Okay, so one of my choices that I have on my list is about caching uh, addresses. So let me just, first I'm going to look for Stackleys. So here, for example, we load the same exact number on the stack. That's waste, right? We already had V22. So we could cache these in the same way as we cached other things. 60, 70, 80, 90, 40, EO, 100, 110. There we're not really... Oh. Wait. I see. So we're filling out a bunch of any's. Like we could get rid of these Stackleys for sure. I don't know, but they're not all to the same item. 150, 160, 170, 180, 1 EO, 1 FO, 200. To DO, to FO. Like there's all this Stackley move, right? Or whatever. Actually, that's putting a pointer of something somewhere else. But Stackley move. This is not really necessary. And instead of doing all these Stackleys, we could just have a move with target. We could have move to data segment and move from data segment. That is a possibility. That would be big gains, honestly. I think. It just might not be that easy to do. Okay, let's look for some more Stackleys. Stackley, AO, BO, CO, DO. If that comes from getting L value info a lot of the time. Yeah, so there we did two 20s. Up here we're doing two 70s. There's a 70, there's a 70. There's a 70. There's a 70. But these wouldn't cross-reference each other because they're in different basic blocks. Boy, we like that 70. Oh, here we're Stackleying to 74 different times, so 3 of those would go away. 20, 20, 20, 20. Okay, so in some cases, all of these Stackleys right here are redundant except for the first one. So in some cases, this would be big gains just to do the dumb thing. The question is, I mean, we might as well. Maybe. Line 934. Where was the really redundant one? 934. Where were all my 20s at? 934. That's sort of the problem one. Emit stack pointer for a declaration. But this is not even like, the thing is, we don't even really want to do things this way. I don't think. Let's see. That's a do placed assignment. That's fine. Copy R value to stack. I actually want to know like where people came from to get there. We could look into that later. I'm starting to get a little tired and want a break, but there's not that many calls to it. Emit scope entry eval. Oh my God, seriously? Oh, if it's got a linear allocation. Let's look at the function for a second. See if we can guess where all this is coming from. This is simulate line 163. So it's this value t probably. Right? Or something. Except, so this is like some float stuff, but what's all this down here? Line 165, 166. Like what, why is that a billion things? So here's our operator times. We load the address. We're going to cache this right now, and we're going to see if there's a better way to do it later. Reduce. Reduce. Emit stack pointer. Okay. But we will also cache it. Find or emit stack Lee for this and decal. All right. Find or emit stack Lee. Okay. All right. No output yet. We're going to see a lot of dumping because we left dumping on. That's a pretty good Weissman score. And it runs. And like I said, we can probably do a lot better than that, honestly. All right. That's great. What's our current gains number? 360257. Remember how I said it would be nice to hit 350? I think we will now. 360133. 360251. We'll take the 57. Look at that. Look at our Weissman score, guys. This last gain is about to get a lot bigger because the thing is, firstly, we can do this more, but secondly, we can do this with global variables too, and it's the same thing. So this thing, we'll see if we get more of a gain just from doing it on the stack. So stack L value. That's not really going to do anything. Add emitted string literal. That's not going to, caching that's not going to do anything. I don't think. Find or emit vargs array. Oh wait, we're allocating right here. Anytime where we just allocate, it's not going to help to call the other thing. All right. This value placement could do it. But we're going to have to change this to linear allocation, which we probably should anyway. Do we use stack pointer register? I don't think we do. I guess we do. I'm going to maybe say remove that. Okay. So this is going to be linear allocation. Okay. While we're up here, we're not going to use this one yet, but we're going to go emitted segmently, and that's going to have Lee segment. That's going to have linear allocation law. All right. That's just law. Okay. See if we get another gain out of that. We might get a very small gain. I don't think it's going to be huge. Yeah, minor. 360130, 360152. Let's call it that. 360152. Okay. Small, but on the board. Now, we're going to do the low-hanging fruit for the other stuff. So we're going to have a find or emit segmently. Okay. So we do a segmently. segment leads.add. Okay. Does that compile? Now we are not calling this yet. Bleh. Segment leads. Okay. We are not calling this yet. Where is this? Scope entry, okay. Frick! We fill in the thing later. That's going to make it hard to do there. All right. Interesting. Find remit segment Lee. Builder. Lee R data info linear allocation. Okay. Let's just try that and make sure it didn't break. It's not builder, it's this. This. Did it break? Will it blend? Okay. No noticeable improvement for that one. But that's fine. Because its power might come from combining with other things. Oh, this is for an array literal, so it's like, it's not really possible to have that twice. Struct literal, same. We're just going to go for the shorter code. Are these literally? No. Yeah, these are the only other segment leads. Dang it. Okay, so the problem is we're doing something. Let's make sure we didn't break something. We're doing something that's preventing me from really doing this. Which is we're like filling in the target register later. We're setting L value BC. Okay. We can actually do this further up. And this is better anyway. This is just better form because I'm going to want to do register tracking anyway. So we like... I'm actually not sure why I think I need to do all this. Yeah, so we don't use that anymore. And honestly, we're doing the same thing. We're just putting a different... Yeah, we can factor this. This is no longer true as well. My mega warning is no longer true because I fixed that a long time ago. All right. This can get cleaner. I guarantee it. Oh. Let's make sure we didn't break that. Didn't get any smaller though. Oh, because we didn't call the thing yet. But we removed the barrier to calling the thing. Let's make sure the test didn't break. I remember putting that mega warning in, by the way. Those were the days. Okay, this one also, we just cleared that up. However, yeah, we're going to rearrange this some more, but here we're going to say emit segmently, right? Right here. We're going to go, oh, that's a register. Find or emit segmently. Right. I mean, okay. It's like, why do we think this even can happen? Anyway, so I'm just trying to, before I take my break, I just want to be able to call find or emit segmently with Lee data right here, or Lee BSS. Okay, now the problem is sometimes we're trying to use register plug. Actually, let's put a placement there. This just needs to be burned with fire. This whole function, dude. This whole function. Okay. This is like cleaned up enough that this isn't gonna matter. Like, there's no real reason why something in BSS should be different from something in the data segment anyway. So, like, just none of this. I think this is just very old and is not even necessary. So the thing to work out, let's make sure this still works. And then we'll figure out how to call the other thing. Set comment. Oh, on BC. Yeah. We're not going to do that. We want to be able to get that comment, but right now we don't. All right. Anyway, this will be good gains to delete all this code that I don't think is necessary. So now it's just like, look, if it's a big R value, okay. So here's what we do is we say placement. L value placement. Okay. Okay. Find or emit segmently takes a value placement, and then I forget how to use this. Okay, so if we emit a Lee, we could do this. plug or allocate placement pointer what is this size for? Plug or allocate placement bytes. I don't know, dude. Oh, right. I'm not sure about this. We're going to see what happens there. Great. Great. Look at all this emitted constant stuff. May just have to go into its own file. Oh, it's that I didn't do this. Why do I even have this? Okay, we don't pass placement here. L value result. Come on. Segment, linear allocation. Oh, it's fourth. No, okay. We didn't. Placement. Duh. This value placement stuff is another way to make gains, but we're not really working on that right now. So I just have to keep things in place for it. Okay, well, we broke that. Congratulations, everybody. This was supposed to be easy, and it turned out to be hard, but that's because it's interfacing with some really old code that, like I said, needs to be totally burned with fire. And we might do that later tonight. Because that was one of the things on my list is like, I need to go through and clear out all the stuff that happens when you refer. There's way too many ways of referring to variables that are too complicated. So let's just ignore the placement for now. That could be what's broken. It might not be. We're free to ignore a value placement. It just means we might end up with a register copy later. Okay. So we're doing the placement wrong in some way. And we used to do the placement. So that might mean we lose gains here. Our gains might actually go down. And I'm not sure if I actually checked in with our high gains. We'll see. Burning old code is always fun. It's a good feeling. It's a good feeling. All right, let's see what our Wiseman score is. Not bad. Not a bad Wiseman score. I didn't expect it to be that good. 357,626. Does it run though? It does. Oh my goodness, guys. We're near the mythical 350. Executable is even substantially smaller now. Look at that. We have made gains on this stream. We're going to make more gains later tonight. There is more that we can do. Believe you me. How many frames am I getting on the big test level? Well, let's see. I want to build this, by the way, with release compiler as an additional test. Make sure we didn't hose things. We've made so many gains. This is great. All right. Let's see what the time is. I have to turn off all the dumps, though. Let's not do that. All right. So probably not going to be that much faster. It's just every little gain is just a little bit faster. Like now we're hanging out on 18 FPS more than we were before, right? Now it's mostly 18 with a little bit below 18, whereas before it was like back and forth a lot more. It's very subjective. But like, you remember when it was 14? Yeah. I mean, yeah, no joke. No joke, our debug build performance has gotten a lot better. Not nothing. That is true. Okay, we might pause the gains for a while in the next stream, because the next stream I think might involve just burning down that code that we were just looking at. Okay. I'm going to put on my list refactor emit scope entry eval. Oh my God. So that I can check it off my list, let me check in this quaternion from Sokoban. Oh no, that's not there. That's in modules. Oh, did I check that? Wait, what? I did. Okay, great. All right. Incomplete address uses. I'm just going to delete all code having to do with that. And if it turns out we needed that for some reason, I will rewrite it in a better way. But I don't believe that we should. If we need that, we need a lot of things. All right. I'm going to get rid of that. I'm going to get rid of this. Poke completed address uses. All right. Might have to come back. I don't know. We'll see. Empty controlled statement found. It's because it's a release build, guys. Let me just make sure set comment. Actually, no, we'll just let it reset to null even. Oh, Visual Studio. No, it was more like 14 before. It might have been 5 in the way distant past. But that was also before the rendering engine was rewritten and stuff. Well, we're above 55,000. I've been writing a lot of code today. I was a little bit scared by how much code I was writing, but we also deleted some, so it's all good. All right. Commit. All right. Very good. Oh, I've got a no check-in still. No. Oh, look at this. Look at this. Okay. Great. Bam. All right, everybody. I'm going to take a break. We'll probably do another stream tonight. Let's find someone to raid. AMD will take years to catch up to Intel. No, I think they mean the opposite. I think they got that backwards. Okay. Timber, is that the Timber Yard Amazon? Timberwind, no. Okay. What looks good, everybody? What is the right thing? Could rate Strager. We just did Strager recently, and then he rated us yesterday or whatever. I don't see anything that's really calling to me. Why is there so much bot development? Could rain moon. I don't know what moon is. That was just a dude. The quantum physics thing was just a dude watching a Leonard Susskind video. It wasn't live. All right, I can't find anything. What is this moon? If it's not good, you're banned.
I'm on a pillar for 40 seconds to keep myself alive.
Yeah, no, what? What are you talking? Why would we raid Overwatch gameplay? All right, everyone, we tried. Couldn't actually wait. What's the timber yard?
You're your favorite.
Oh my god, that's so loud.
Probably because it's easy. And that's all you're doing in Ghost 2. In Ghost 2 you can only fancy major most instruments.
All right. Not English half the time and also doing audio, I guess. So we're not going to raid that. We'll do Strager because Strager rated us, right? Thanks everyone for coming by, and I'll see you later.